Hey Algebra 1, and thanks for tuning in. Today we're going to be looking at lesson 6.4 and how to figure out if something is exponentially growing or decaying. We're going to be looking for 8 things in our notes. Let's go ahead and get started. The first thing we're going to talk about is what is exponential growth. What we're essentially just going to do is write exponential growth function and then copy and label this equation right here. This is basically just a breakdown of what you're going to be seeing in some of the representations of exponential growth. You have y, which is your final amount. A is your initial or starting amount. And then in parentheses, you have 1 plus r. R is the rate of growth. That's written in decimal form. Sometimes, though, it's usually given in percent form. You just need to change percent to decimal. And then that 1 plus r, that's how much it grows. And then to the t power, that just means how much time there is, or how much time has gone by. Let's go ahead and take time now to pause the video here so you can write down the formula for growth functions. And then once you're done, click play and you'll see how to maybe determine if it's growing or not. So this is an example of what you're going to be seeing for homework. It says the inaugural attendance of an annual music festival is 150,000 people. The attendance Y increases by 8% each year. Write an exponential growth function that represents the attendance after t years. So just remember, we are using that growth function you just wrote down in your notes. The Y is equal to a parentheses 1 plus r to the t power. And all we're going to be doing with that is filling stuff in. Y represents the attendance, so Y is not going to change. A, remember, is the initial amount, so I'm going to write 150,000 because that's the initial amount they're giving us. And then in parentheses, I'm going to write 1 plus R. R would be the decimal form of 8%, which is 0.08. And then it says after t years, so I'm just going to keep t as my exponent. Now, we could go ahead and simplify this 1 plus 1.08, which would mean our equation would finally be y is equal to 150,000, parentheses 1.08 to the t power. Okay, so this would be our answer to letter A. Pretty easy and simple. The next thing, though, is going to take you a little bit of time with your calculator. It says how many people will attend the festival in the 5th year. So think about this. In the 5th year, you would want t being equal to 4 because year 0, or technically because 0 is year 1. That's when we started. So we have 0 would be year 1. 1 after 1 year, that's technically 2 years that it's gone by, and so on. So when we write our equation, we're going to say y is equal to 150,000, parentheses 1.08, and not to the 5th power because, again, we're starting already with some people there. So we're going to say it's to the 4th power because 0 would be 1 year, 1 would be 2 years, 2 would be 3 years, 3 would be 4 years gone by, and then 4 would represent the 5 years. Okay, so what I'm going to do is just plug this into my calculator. First, I'm going to do 1.08 to the 4th power. You can do that just by multiplying 1.08 by itself 4 times, or there's an exponent function on your calculator you get to use in class, and you can use that as well. Either way, you're going to be getting about 204,703 people. It does say round to the nearest 1,000 for your answer, so we're going to say about 204,000 people. Okay, so the only thing that you have to really be careful is the years. And we'll do more examples so you can get more comfortable with that as well. So here's the question that you're going to try. You have part A, part B, very similar to what you saw yesterday, or just now. So let's go ahead and look to see what our answers are going to be after we try it. So let's go ahead and pause. You're going to write your equation first, and then once you're done, click play to check your answer. So the first thing we want to do is go ahead and write our initial amount. So y is equal to 500,000. And then in parentheses, we would write 1 plus 0.15 or 1.15 to the t power. Okay, you do want to make sure that you simplify the 1 plus the 0.15, just because it makes it a little bit more simple to look at, and you're going to start noticing that growth always has a number above the number 1. The next part says how many members will there be in 2016? Round your answer to the nearest 10,000. You have to be careful with this one. This one, the year is a little bit different because it says there are members in 2010, not after the initial part. So 2010 is year 1, and 2011 is year 2, and 2012 is year 3, and 13 would be year 4, and 14 would be year 5, and 16 would be year 6. So our t would be equal to 6. So with solving letter B, you would need to do 500,000. So you're there, good. And then times 1.15. And then this would be to the 6th power. Okay, you do get a large number, 1,156,530. It does say round to the nearest 10,000. The nearest 10,000 is this 5 right here. And notice the neighbor is a 6, so we would just bump it up to 1,160,000,000 people. And since we rounded, we'll just say about 1,160,000. Okay, so just be careful. It'll be different when it says in 2000, that means 2010, that means it's starting, versus after that initial amount. Okay, that was the only difference between the one I did versus the one you just did in your notes. The next thing we're going to talk about is exponential decay. So let's go ahead, we're going to label exponential decay and write down the function. It is very similar to exponential growth. The only difference is the decay factor you are subtracting. Okay, everything else is the same. So whenever you copy this down in your notes, make sure you have the subtraction sign and represent the decay factor. Again, let's go ahead and pause here so you can have time to write. And once you're done, click play so you can see how it's done. So the first thing we're going to look at is when we're given a table of values, we're going to try to determine if it's decaying or if it's growing, or if it's neither. And I'll tell you why it would be neither. For this first one, you notice that x is increasing by 1. So each thing is going, each item or each value in x is going up plus 1. In the y value column, you can say we're either dividing by 3 or timesing by 1/3. So everything is being divided by 3 or timesing by 1/3. Since your x is increasing and your y is decreasing by either multiplication, y would be decreasing by multiplication or division, this one we're going to say it is decay. Because as x increases by 1, y is decreasing by dividing it into thirds or timesing it by 1/3. Okay? If we look at letter B, again, let's look just straight across at the x values. Again, x is going up by 1 each time. Add 1, add 1, add 1. Here, in y, we are timesing by 2 each time. Since x is increasing at a steady rate and so is y, we're going to say that letter B is a growth function because x is increasing by adding 1 each time and y is increasing as well by multiplying by 2. Example of it being neither would just mean you're simply adding. For both. When it is exponential, that means there are multiples. It's multiple of the growth. So if you're just adding, that is not showing multiple growth or multiplying with growth. Okay? Just keep that in mind for the next slide. Here are two that you're going to try. So again, let's just try to figure out, once again, is this an exponential decay or an exponential growth? If it's neither, you just write neither and explain why. Let's go ahead and pause for number 4 and 5, and once you're done, click play to check your answers. Alright, number 4, I got decay. because x is increasing by 1 and y is decreasing by dividing by 4. For number 5, I got neither, because x was still increasing by 2, but y was simply increasing by adding. And because we are looking for exponential growth or exponential decay, adding is not showing those exponential forms. The last part in our notes, we're just going to determine if it is exponential growth or exponential decay and identify the percent rate of change. An easy way to tell in letter A is notice how it is larger than 1. So if we broke that down, before they simplified it, it would be 1 plus 0.07 to the t power, which means that your rate is 7%, because 0.07 is 7%, and that would represent a growth because your percent is higher, or your percent was not subtracted. For this one on letter B, it says f of t is equal to 0.2 times 0.98 to the t power. Again, if we broke this down, they have to start at 1 no matter what, but it looks like they subtracted. To get to 0.98, they probably subtracted 0.02, which means that your rate is equal to 2%, but this would be a decay because this number is less than the number 1. Okay, that just represents decay. Greater than 1 represents growth. So here are 2 questions like that you're going to try. Determine if it represents growth or decay, and then identify the rate of change. Let's go ahead and pause the video here so you can try these 2 on your own, and once you're done, click play so we can check our work. So number 6, this one is a decay because it is less than 1, and the percent is 8% because we subtracted that from the 1. We got 0.08, which means 8% would be our decay. For number 7, though, this one would be considered growth. And to get 1.2, they had to add 0.2 to 1. So that would be a 20% growth, which is an astounding amount of growth for exponential form. Okay. The last thing I'm going to have you do is just write down and define what compound interest is. This is going to show up in eventually in your test, so I just wanted to maybe explain compound interest. This is what you see whenever you have interest earned on a principal amount. It is technically exponential because of how it is calculated, but P would represent the principal or the initial amount. The R is the annual interest rate in decimal form. T is the time in years, and N is the number of times the interest is compounded per year. Sometimes interest is compounded monthly whenever you have like a credit card expense. Sometimes interest is compounded daily, so then you have to divide it by all the days of the year. So that's just something to consider here. Let's go ahead and copy down compound interest. I'm going to get you to pause here, and once you're done, click play to finish up. So that's going to conclude our notes for today on exponential growth and decay. Thanks so much for tuning in, and we'll catch you next time.